Action.
Yeah, first of all, I would like to welcome everybody to this presentation. I hope you will enjoy it. This will be a short introduction of the logical operations and expressions. First of all, I would like to tell you some words about the content. This will be the three main topics I would like to tell you. First, I give you the definition of the logical variant, and after that we say some words about the operations we can use in this topic, and finally we try to evaluate a logical expression, and I hope you will enjoy it. First, I told you that I will define the logical variant. So it's very simply, because it's a variant, it can have only two values, the true or the false. In most cases we use the sign 1 for true and the 0 for false. There's no third choice. That means if a variant could be get other value, it couldn't be a logical variant. We can make logical operations with this variance. Operation is like we use with numbers, like addition, subtraction, multiplying, or division. And of course the result, what we will get, will be value, a logical value, like true or false. We can make a lot of operations, but we don't have enough time to mention all of them, so I choose some and we will see only this. The first, what I show you is a logical operation with only one variant. This will be the negation. We use in the most cases the not operation, so this works. This is a symbol for it. We write the word not in front of the variant, and you can see the truth table of this operation. That means that we evaluate the values of the variant. If you have a false value, look at here, then the result will be true, and in the opposite you will get from true to false. Now comes some logical operations with two variants. The first will be this junction. We say in most cases this is the OR operation. This will be the symbol for it. Of course, x1 and x2 means the two variants, and we use the OR between these two symbols. This will be the truth table of this operation. You can see we have 4 input data, and it's important to know, so don't forget it, that you can get the false value only in one case, if the 2 input data are false and false. And I have a program for it. Maybe I can show you or demonstrate how it works. So if I choose the 2 false values, the result will be false, of course, and in the other cases you will get the true. If you're happy, you press X. Okay, then the second important operation will be the AND operation. We use the conjunction name for it. This will be the symbol. I think you can understand. It's really very easy. And this will be the truth table for it. There's only one thing that is important to not forget. You can get the true value only in one case, if the 2 input data are true. In the other cases, the result will be false, and if you want to test it, you can do it with this program. So we use AND, of course, and the result will be AND, and in the other cases, the result is really and. And the last, what I would like to mention, will be the XOR objection. Yeah, this is the exclusive disjunction. This is the symmetry, and we can see the table that contains the results. You can get the true value only in two cases, if only one input data is true and the other have to be false. Okay, so if I would like to demonstrate it, you can see that the result will be false if the two input data are done again, and if I choose the other two opportunities, then the result will be true. Okay. I would like to demonstrate this operations with Max and Gina, like we do it with sets in math. Max is a rat and Gina is a rabbit, and here they are together. And if I want to show you not Max, this will be everything outside Max, of course. And if I would like to demonstrate not Gina, it's everything outside Gina. Max or Gina means everything what is in Max or is in Gina. Max and Gina means only the common part of them, and finally we have Max XOR Gina. The common part is missing, of course. There are some equations we really like. These are the Morgan equations. De Morgan was a man who wrote down his idea. These are two equations with these operations, of course. And maybe you can ask me, why are they important? Because we can simplify other logical expressions, and in that case we are able to make logical electronic circuits easier. And now some few words about the logical expressions. If we connect logical variants with these operations together, then we get logical expressions. And it's very important, if you would like to evaluate a logical expression, to look at the order of these operations. First of all, you have to evaluate always the not part, and then the and, or and XOR are the same. And finally, if the operations have the same role, you can go from left to right, because we live in Europe and not in the Arabic world. Okay. And finally, an example how to evaluate a logical expression. You can see here, this is not x1 XOR x2. We can see here the two input data, x1 and x2. We have four opportunities, four possibilities. And first we have to evaluate not x1, and finally we can get the result when we put this x2 and not x1 together with the operation of XOR. You can find useful links on the internet if you are interested in this topic, and I hope this few or short introduction was enough to make you happy. If you enjoyed it or you have some questions, I'll try to answer it. If you don't have questions, I won't. Okay.
What kind of marks can you use? Instead of the letters and or.
You mean signs?
Signs.
There are a lot of. So maybe we have a pen or. So this is the mark for and. This is the mark for or. So like in the female and male word. So this is or. This could be the and. And in the most cases, we can use the marks or signs for this operation like with numbers. So plus is equal to, or the point for multiplying is good for and sometimes if we would like to use a mark for XOR, we write the plus into a circle. And for the negation, we use this upper line, or I don't know how to say it. Maybe this is the correct expression for it. Any questions? Maybe.
Can you describe this logika with electronic circuits?
Yes, of course you can. But not now. So I think it's too complicated. But there are other methods, physical methods we can really if you, for example, if you put some two lamps or switches together in serial connection, then you will get the operation and if you connect these two switches parallel together, you will get the operation or yeah. I think these are the main keywords. You're welcome. If no more questions, then thanks for your attention.